I'm Ashton Addison from the Crypto Coin Show, and today on Blockchain Interviews, we have back with us Jag Sidhu, core developer of Syscoin, here to talk about Syscoin's protocol, a mixture of proof of work, proof of stake, ZK, AI, quantum resistance, and all of the topics that Jag is always researching and on top of. I'm excited to get the latest. It's been a while since our last interview, and we've done many over the years. So thank you so much for taking the time out of your busy schedule again, Jag.
Yeah, it's always good to catch up with you. It's usually I found that I was speaking to you before that it's we usually do these interviews at the time when we have explosive growth in the industry. So hopefully that trend carries on. And yeah, we always have pretty good interviews and you ask great questions. So I'm always happy to catch up with you and see what you're up to and explain what we're up to as well.
Yeah, I always appreciate your insights, and the narratives continue to grow and blockchain continues to get better, as well with the integration of AI, which is actually starting to bring in some functionality, not just ramble on what AI can do. So I'm excited to hear your latest insights. I would love to kick it off. For those who aren't familiar with Syscoin and what your team's been building over the last 10 years, if you could talk a little bit about the Syscoin protocol and the consensus of the Bitcoin, Ethereum, where it all fits into the blockchain industry, and then we can touch on all those topics.
Yeah, yeah. So we've been sort of doing this around Bitcoin for a long time, and the thought process is that you need the ability to build a side chain in a way that's mutually beneficial to Bitcoin in some way. Initially, there was no bridges, and so there was no ability for people to migrate from Bitcoin into an alt chain. So that's why they called them altcoins. They were alternates or universes of crypto. Many people just decided, okay, we can build better Bitcoins. Our thought process wasn't to build sort of a better Bitcoin. It was more, how can we connect it to BTC? But since there was no bridges, we were classified as an altcoin in a traditional sense because we were building, our own little ecosystem. But now, like with the advent of stuff like BitVM, which we fully expected either covenants to come in for better bridges, or someone was going to figure out a ZK or some system like this is basically a optimistic solution that allows people to bridge Bitcoin. And it's interesting because now our design fully fits into that model and completes a picture of instead of just an alt, it's more of a connection into Bitcoin. And most of the coins that are not going this direction are going to be considered more alts and will have a tough time struggling against the explosive nature of Bitcoin and its and the way it's structured and designed.
Yeah, no, it's hard for altcoins to compete with Bitcoin, and that's sort of what they've done without the compatibility of Bitcoin in the Bitcoin blockchain. So what you're saying is with this new bridging technology, you're actually able to bridge Bitcoin and Syscoin together. So how does that work with the blockchain and with the coins themselves?
Yeah, like we've always been like an extension. We thought ourselves an extension of Bitcoin, but we never had the actual bridging to make that extension really a reality outside of maybe trusted bridges for the past while. So we've been assuming that there's going to be something coming. We will, prepare our evolutionary design based on how we proceed with scaling blockchain in a traditional sense, like how we build, how Ethereum thought about scaling in a modular way with data availability and rollups and putting all the computation on extended layers and trying to keep the layer one, in this case, Syscoin, to be as minimal as possible with light nodes running it. And those things matter in a decentralized sense because if half the internet went down at any point, the system needs to be robust against that, and there needs to be enough nodes. It can't be just a cluster of nodes that are 15 validators running the whole thing, and then you take those down and everything stops and it's done, right? Like, especially with AI, and we're getting some infiltration on AI bots on our servers. When that gets worse and worse, and it is getting worse because you can't detect if it's a human or AI now from the perspective of spam attacks, it's going to get so bad that the server is just going to be taken over. you need to be robust in a decentralized perspective to combat that. So having the ability for regular servers or lighter servers to keep up with the state without any trust is critical. And so you got to build it up with all of the data and all of the network to be able to reproduce the state on every machine. The Ethereum ecosystem is quite large, but it's going in the direction of modularity. Many of the other blockchains are monolithic, and they just try to put everything in one layer, and it's very hard for average computers or average servers to sync that up. So you do need these special computers. How many of them will be around in the world, I'm not sure. And even Bitcoin is pretty light. I mean, it takes a couple of days to sync, but it's not that heavy because it doesn't have the smart contracts. So, we designed it from that perspective, thinking, well, when there is a bridge, at least it'll be maximally decentralized and there'll be a reason to use it. The reason is specifically because of the characteristics of our, quote unquote sidechain that will offer the things that, someone like a Bitcoin user will want, namely smart contracts and the security, decentralization, and the flexibility of a design that's robust against these sort of attacks. Bitcoin was designed for that, right? It was designed to withstand nation state level attacks. And many of the others, they don't start that way. They start with, how can we just make something that's maximally useful rather than maximally secure and decentralized? I think Ethereum started on the right foot, but ended up quickly becoming, well, oh, cool, you could do ICOs, you could do tokenization, let's let this run. And it ended up having problems with, okay, we have a huge issue with state and the blockchain is just too big, so how do we solve this? Well, we took all those ideas and we created something that we think is, from day one was mutually beneficial to the industry, but also making sure that as we grow, then we won't have those same problems. We start from lightweight security decentralization first, and we build on top of that. So the final pieces are just connecting back to Bitcoin, and that's what's sort of happening now.
Yeah, that's really cool. And I'm glad you mentioned there about the fact that AI can have attack vectors on blockchain. There's been a lot of discussion over 2024 in how AI and blockchain have synergies together, which they do. And I've been seeing more functionality coming in with AI where you're not just typing to an LLM and they respond and then you have to go do actions yourself. They're actually able to take actions on your behalf and contribute to a blockchain ecosystem or a DAO or any other functionality like trading. We're starting to see that. But there is, and there has been, that notion of, okay, could be a dark side to AI. It could, take over. As far as take over the human race, we'll see where that goes. But in terms of attacking blockchains or finding ways to manipulate, I'm glad that you mentioned that, because it's not something that people mention, because I think that they really want to prop up blockchain, the people that are talking about it saying, blockchain is good with AI. There's all these functions you can do, but nothing is ever 100% good.
Yeah, I mean, just thinking right now as you say it, as long as there's resource contention, like as long as there's demand for some sort of resource, then there'll be a need for bartering for that resource, which means there's a need for some sort of money, whether that's the definition of money that we have today, or maybe some effort-based or work-based monies like Bitcoin, or some sort of way to do an IOU that I will give you something, you give me something in response. That's going to vastly change in the AI landscape, right? Like it's going to, the thing is, as long as you have that, you're going to have manipulation as well, because someone's going to want that resource at the expense of the other person. It's a zero-sum game. So you will always end up having situations where either the AI manipulates or the human is telling the AI to manipulate to maximize their own utility function to benefit themselves or the group or company. That's always going to happen, and that's the problem. So as these systems get more powerful and they're already at the IQ level of the average human or more, and you can span up agents now and basically do anything. and the agents can become autonomous. The only missing piece is just having them completely autonomous, where they're just recursively working within themselves with their own agendas, which hasn't happened yet. But if it was to happen, we wouldn't know either, because they would be smarter than us. So we wouldn't know if they're acting on their own behalf or not. They may just tell us that they're just doing stuff we're asking them to, but behind the scenes, it may be like setting up a sort of a trap. And we're seeing a lot of spam on servers, on our own servers, around AI agents. And we think they're AI because the headers are not set, and they feel like it's a normal browser that's using these systems, or a normal user without the headers that are normally set by bots. And it's getting increasingly difficult to detect that. And the attacks are becoming more sophisticated. And my personal view is it's probing happening. Agents and AIs probing which servers are available, because again, because of resource contention, servers are always needed to either expand its own footprint, or duplicate itself, or have access to some computing in some event that it's needed. It's spamming and DOS not getting them. It's not winning you money, but it's maybe setting something else up, and we're seeing that. But the utility part of AI, we're seeing software increasingly more robust and speedy in terms of development. So I think 80 or 90% of the software in the world is going to be developed by AI by the end of this year. Wow. If you're not using AI, you're falling behind. You could be the best software engineer in the world. You're going to be behind everyone else. A 15-year-old kid is going to be doing better than you. Last year you would have been, top 10 in the world. This year you're top 1 million because of that. So it's going to be pretty crazy. So use cases, who knows what those will be, but the ones we're thinking is, we're trying to take a general approach to it. Like, you need to have a private key management system. You need to have, if you don't have the ability for the AI to say, I will hold my private key and I will operate my own wallet, because maybe that could be hijacked, or another AI can hijack that through prompt engineering. You definitely need some sort of consensus amongst AI agents to decide actions. Like, for example, you mentioned DAO. Like, if there's an investment vehicle, it's probably going to outperform any other vehicle if it starts today, because it's much smarter. So it'll be able to detect trends in the markets and arbitrage for this information asymmetry, and get information faster. It's got the whole world indexed into itself, so it's able to know and make decisions in a better way to make more money. But the thing is deciding on those, where we should allocate capital, who funds it, who decides, and maybe, big decisions like big blocks of money that get moved into places that they should be decided in consensus, not just like one agent deciding. So AVSs and mechanisms to basically secure those decision-making tools, even private key management or funds management, like maybe like basically like a big multi-sig between agents, is something interesting that's happening. I think Eigen is working towards. Actually, Eigen is becoming a verifiable infrastructure in the cloud for AI agents. That's all it is now. It's not doing any, like, initially it was a proof of stake blockchain bootstrapping Ethereum security. Now it's AI agents, AI decision making, sort of consensus mechanism. And we've been thinking about this independently, reproducing mechanisms like Eigen, thinking that's where it's going to go. And use cases could be many, but like the main abstract is you need to give them financial power somehow without someone coming in the middle and extracting that. And the only way to do that is having groups of them sort of agree that this is the right decision. So that's one big intersection between the AI and Bitcoin. I think has its own sort of story there. That's probably more like a political thing rather than like a technical challenge with AI.
Yeah, I think Bitcoin's probably safe from AI. I would hope so, with the security level that it has. I don't know about the other altcoin chains. The smaller the market cap and the decentralization of the network, the more susceptible I could imagine it could be taken over by AI. So I'm looking forward to seeing the positive side, how it grows with blockchain and that functionality coming in to automate things, and hopefully DAOs can get better, trading and portfolio management and wallets of AI agents, and that can extend into deep-in networks and autonomous vehicles and humanoid robots that have more crypto in their wallet than you. So we'll see where all that comes in the near future. Now, I want to go back to Bitcoin because I know you know a lot about it as building the sidechain to extend functionality, and part of that is the BitVM, or the virtual machine that ties into Bitcoin. So with Syscoin, does that allow you to stake Bitcoin, create DeFi apps that are on the Bitcoin chain, and sort of do everything that Ethereum dApps could do, but on Bitcoin?
Yeah, so BitVM's initial premise was you can run smart contracts on Bitcoin, right? But they quickly realized, ZeroSync guys quickly realized you could do that, but you're emulating all of the opcodes. So for example, like 1+1, you'd have to push a number to the stack, do an operation, push another number to the stack. With opcat, you can concatenate things and recreate state with be able to say this is the block hash of this block, therefore I can check that the state is correct, it's correctly committed to the block hash. You can't do that on Bitcoin today, but those scripts become huge, right? There's only with SegWit around 3 point something megabytes to play with in Bitcoin, and a general smart contract like an ERC20 transfer would be like a megabyte or 2 megabytes of just operations to recreate that situation of being able to transfer funds, right? And then on the other hand, you wouldn't be able to use actual Bitcoin because these operations are pseudo assets that are settling on Bitcoin. But to do actual Bitcoin, the Bitcoin is locked in its own UTXO set. It's not it doesn't have any awareness of what the VM is naturally, right? And so yeah, BitVM is basically it ends up being a vaulting design. You have the ability to lock BTC in and then create some pseudo BTC in the system, and BitVM and BitVM2 are basically a way for you to lock and unlock Bitcoin within that. And its general purpose smart contract design is just the ability for you to be able to say a simple thing like, I have Bitcoin on the side system, I want to get my Bitcoin back out of Bitcoin, or I have Bitcoin in BTC, I want to lock it, and I want to give you should get Bitcoin on the side system. Most of the the BitVM guys are thinking, well, the maximal security is if you just do this right on BTC, right? You run the side system, settling all of its data and transactions onto BTC, right? And then you're running a roll up on BTC. All of the data is just ephemeral sort of data that's maybe 1 or 2 megabytes of transactions. It's not scripts. It's just basically compressed data of the transaction. You store that in the op return of Bitcoin, and then you run your ZK rollup or something, and your BitVM is a connection between that rollup and BTC with the data. And there's some teams doing that, and it's a viable direction. It's just that you run out of space pretty quickly again. So even if you're compressing all the data and you're saying it's a ZK rollup and only the differences of transaction accounts are being posted on Bitcoin, it still quickly runs out of data. It might be a better solution than if you're using Lightning networks for some sort of payments. Maybe it's you could do DeFi and stuff. We're saying that's a valid thing for a design, but we think if you use sidechains, you get a lot more flexibility, right? And no one's gone that direction because BitVM hasn't been around that long, and many of the sidechains, they had to make custom decisions. Like Stacks did proof of transfer, and Rootstock had some functionaries that are running trusted execution, like Intel SGX chips that act in unison. There's 10 of them, and they all have to agree that a bridge transfer these are all custom designs, right? And they're quickly having to pivot now because of the general purpose nature of BitVM and BitVM2. You don't need to have these custom designs built in to connect a sidechain into Bitcoin. You have new ways to do this, and no one has thought of these new ways. But when we were designing Syscoin, we didn't want to think about how to connect it directly, because we knew that there was going to be something that's going to give us the ability to do in a general way in the future. So for now, let's focus on how we can maximally decentralize and settle a lightweight system that will give us the ability to execute in a very scalable way without affecting the security. All we needed was merge mining to start. The merge mining gives us the ability to have the Bitcoin miner secure our system, not necessarily bridge, but just secure our system. Now what we're seeing is the bridging, and that's sort of the final piece, is actually vaulting the BTC and then moving it over. And most of the solutions today, the rollups, they are bridging into BTC and settling on BTC. Our research has been, how can we do that with the sidechain? All the other research that has been to try to connect sidechain to BTC has always resulted in that you have to trust a multisig, or you have to trust that your sidechain won't get compromised in a 51% attack or a 66% proof of stake attack. That is the biggest challenge, and people are not willing to accept that, because if, say, 10,000 BTC get locked up in that vault, and the cost of attacking that sidechain is, I don't know, way less, then someone's going to do that and going to take that, potentially take the 10,000 BTC or double spend that. And that's the challenge, and BTC people are not willing to accept that. So for us, we were like, can we improve that through our research? And we did find a way to potentially improve that with respect to sidechains. And it could be applied generally to other sidechains. But then coupled with Syscoin's design, it gives us the ability to do all the other stuff we've been really good at with respect to how to scale a blockchain before we connected it to the bridge. But now with the bridge, it sort of completes the picture for us and checks all the boxes. Not only gives it better security than other sidechain-based bridge designs, but the modularity and all of the other stuff, the zk stuff that we're building on top, which will apply to BTC users when they bridge over.
Yeah, really interesting, Jag. And I'm curious what do you think of the growing popularity of Bitcoin itself through the ETFs, institutional adoption, the strategic Bitcoin reserve from the US government? Does that have a positive effect on the Bitcoin sidechains and smart contracts on Bitcoin? Do you think that there's any interest, or how long will it take for big players to have more interest in the intricacies of Bitcoin beyond just buying it and trading it?
Yeah, I think the story of BTC, there's different facets, there's different groups. Most of the users don't want to, first of all, when you build a sidechain, or you build any system that's leveraging BTC for utility, utility function of BTC is the stored proof of work. It's not there's a transfer when you're applying it to like economic theory, the transfer utility of this economic asset is the hardness of being double spend protected when you're just transferring the asset. That's it, just a transfer asset. And that's what it's good at. If you try to conflate it with smart contracts and all the other things, then you end up having these, the transfer utility degrades because you have new attack vectors that open up. Like maybe there's limited number of servers, or there's consensus design because the transfer function is expanded to smart contracts. You open up new. So the benefit of Bitcoin is the utility function is based on just very simple transfer function of asset from one to the other. And that's what it's really, really good at, and we should leave it at that. When we're talking about extending that, then you think, okay, which users will care about that? And mainly it's when you're building the sidechain, you can't think of Bitcoin as sort of gas or an asset for gas for general DeFi, because that's not what users really want to do. They don't want to spend BTC as gas. It's not a form of gas. They want to accumulate Bitcoin as an asset reserve, because that utility function of transfer, that's the only thing that they really care about. Is like Saylor would say, like the amount of work being put into Bitcoin over time gives me, lets them sleep at night knowing that if there's 100 blocks of work done on top, there's X amount of money that's burying his state, his utility function. If there's 1,000 blocks, now there's that much more work. And as every block gets added on, it's harder and harder to undo all that. So my utility function, when I just want to transfer from one vault to another, is exponentially, there's more and more utility on that. So yeah, the institutional side, I think definitely is in the accumulation phase. At some point, they're going to want to say, I want to stack more sats, or I want to, I want this to be lent in a maximally friendly, secure way. It's not going to be for everyone, but it's going to be for the people in a deflationary environment. For example, like the media, televisions and computers and all these things. It's a deflationary economy, right? And you still end up buying the TV every Boxing Day because you need a new TV at some point. So you spend when you have to, but you don't use if there was an economy that was deflationary, you wouldn't want to spend that as gas. You would just want to spend when you have to and buy the thing and basically use it. In the same sense, these people will want to stack sats. So they'll make a purchase in terms of, I will move my coin and I will lend it, or I'll borrow against it, or I'll do something. There could be an algo stable. I can put my Bitcoin as collateral, take the algo stable, then I'll go spend that in the economy somewhere. I'll go buy something with it. That's the sort of use case we're thinking is relevant. It's not, I would just want to go and do some ERC20 transfers and, do DeFi with it. It's more Bitcoin as a capital asset reserve, and everything around DeFi, it's irrelevant unless you think of BTC as a capital reserve. And once you think of it that way, then the type of DeFi would be, I put BTC at work by staking it somewhere or putting it somewhere safe and getting stable yields, not thousands of percents, like a few percent on top, given the security model. And the premium has to be, the economy is going to not give too much percent because it becomes Ponzi-like pretty quickly. So it's basically a stacking sats strategy that we think is going to dominate. And that could appeal to every BTC person at some point, but it's going to be a small percentage to start, because most people are happy with Bitcoin going up 100% a year. And they're just institutionals, they're just holding it in ETFs. Someone else is holding their keys. They're okay with it. When it does hit $1 million and people are like, I need to hold my own coins because this is now, like, insurance won't cover me if the loss happens. I'm holding 10 of these. At that point, then you take control over it, and then you decide, okay, now what? How do I increase this to get more of a purchasing power for whatever Bitcoin stands for, whether it's governance, whether it's some sort of capital reserve, if there's a decision-making process and you hold some Bitcoin, it could be a governance tool, and you need to increase that. Well, that's where you apply it to some of these concepts and smart contracts, whether that's DeFi or something else. We want to give the tools for that to become possible. That can't be built on Bitcoin by itself. It needs to be built up into these other roll-ups or sidechain designs.
Yeah, no, I love that you understand that Bitcoin as a capital asset, people don't want to spend Bitcoin as the gas fee. And the point of, if you're going to move your Bitcoin off of cold storage and try to use financial products to earn, then the whole point of that is to get more Bitcoin in the end, not to lose Bitcoin or to be spending it. Spend as little as possible to be able to earn more. I think that eventually it's going to come to that, but we're pretty early, even with the US government getting involved in the last month only, that probably see, although the ETF for Bitcoin has been the most successful ETF of all time, it's only been 1 year. The stock market's been going for decades and decades and decades. It might take a long time for the traditional finance to consider part of that, but I feel like eventually that's something that they'll be interested in.
But I think the SBR, and it's really, really big, and it's market's not pricing it in. I think when Google announced the Willow chip, Bitcoin fell, right? Because a lot of investors they gave up on Bitcoin, thinking that at some point Satoshi's coins are going to move, or the quantum resistance aspect of it, right? I think the government's getting involved is, I think there's less to worry about. For one, we know Bitcoin and every blockchain has to upgrade. It's just Bitcoin is a little bit more on the safety side. It will upgrade to a quantum safe signature at some point. And actually, by itself, Bitcoin uses change addresses, so it's already quantum resistant in some ways. It doesn't need a quantum resistant signature scheme that all these other blockchains are working on. It basically uses change addresses, and so as long as the hashing is safe, it's safe, and that is a weaker assumption, and it's basically gives us more of a buffer, because the first thing that's going to get attacked is the signature stuff. It's like when you sign over a public key, the symmetric cryptography, asymmetric cryptography, like when you encrypt something, like if I'm sending a message to you encrypted, that's the first thing that's going to break. The governments, they're going to go after the government for that. And the symmetric cryptography, like being able to sign something using ECDSA that Bitcoin's using, that'll be the next thing. It's going to be a little bit harder, and this is 5-10 years away, but that would be the next thing. But the change addresses protect against that, because the keys are not exposed. The public keys are not exposed to the world. So the hashing function is protecting. It doesn't protect legacy wallets like Satoshi's original 1 million coins. They're sitting in, a lot of them are sitting in public keys, and those are exposed. But the governments with SBR, for me, they do one thing, and that is knowing that it's too big to fail at that point. And imagine that a quantum computer spends all this risk to go attack Bitcoin, and it's like North Korea or something like that, right? And they basically just get access to it, and they know that they attack blockchains all the time. They just did it recently, right? They go and do that. Now, what do you think the US government would do at that point? With all their military power, they would say, hold on, we're not honoring any of that. You guys go implement the quantum resistant signatures, we do an upgrade, and everyone rolls back to that previous state. It's a social governance tool at the end of the day, these blockchains, right? Every blockchain is a form of social governance. It's protecting against social conditions within humans. The BFT problem is a human problem. It's not a machine problem. It's something between humans and double spend protection. So in the end, humans can just decide, you know what? It's already past the point of no return. As Satoshi said, it's a 0-1 game. It's either worth nothing or it's worth everything. Everything meaning infinity. So at that point of no return, we've already passed that's worth nothing. So I think it squashes the risks of quantum, but it is safer already by design than some of these other blockchains that leave the keys exposed.
Yeah, that's really interesting. I want to learn more about the quantum resistance and quantum attacks. So from what I understood, Satoshi's original Bitcoin are in an old wallet, and there's been little soft forks of Bitcoin that have improved security over the years, and it's possible to make HD wallets and other secure wallets multi-sig. So there's different types of wallets or addresses that have more security, which can be quantum resistant or already are with Bitcoin. And then also you mentioned there about the social governance. Are you saying that there could be a proposal to increase the security even more to become further quantum resistant, and like a further soft fork of Bitcoin to help security?
Yeah, like I think to do, like, there's no quantum signature scheme that actually is as efficient as just the ones that are in Bitcoin today, right? 60 or 70 bytes, and you could do 1,000 within tens of milliseconds, right? On modern hardware. And the quantum resistant ones are a lot bigger and slower to validate. So that's why it's not. But in the end, there are some proposals to make it happen. And if it happens, then we will be forced to upgrade, right? And the government will say, hey, we're going to roll everything back. So upgrade it now. And we'll have to take the best, and we'll take, there's already ones that we know that will work. And we put those in. At that point, the upgrade happens. And the signature scheme of Bitcoin, they'll create a new address type, like whether it's Taproot or something like that, where it's quantum resistant signatures, right? So It may not be Taproot itself, maybe like Taproot part 2, a new type of address that people can use. There may be a migration period where you have the ability to move coins and it's not subject to those attacks, or developers can find a way to maybe migrate those coins. Somehow you're able to sign over into this new address scheme without being exposed to these quantum computers. But either way, because of the human social governance saying, okay, we're snapshotting from this address, it means that, if anyone steals or attack happens and it goes against that, it's not going to be honored. I think that's basically what the government and SBR and all this stuff proves to me, is that it's the point of no return. At some point, they basically will honor. If anything crazy happens, they got basically the government's there now, and they'll just say, take the state and fix it, have everyone migrate, and now you're safe from these attacks for the foreseeable future. Maybe another 5-10 years before the next. And when they do that, they'll make it so it's more upgradable for the future as well. So if another scheme comes out, we could just add that one in, and people can have the option to upgrade to the next safer version on their own.
It's really interesting. And I also want to ask about ZK technology, zero knowledge proofs. I know that Syscoin is integrated with that technology in certain sorts. Does that help with security or scalability? And can you talk about the advantages of that tech with Bitcoin and the sidechains?
Yeah, so ZK is like a black box. It gives the ability to prove something happened almost in a constant space. So if you have 1 million transfers, you can crunch that down to look like one transfer at the speed and cost, and gives these wonderful scaling properties. This is privacy as well. So because it's a black box, you actually don't know what all that stuff that happens unless you expose that. Most of the ZK systems today expose it because of the data availability problem. You have to put the data on the blockchain. Therefore, all the transactions get posted. At least all the differences get posted, and you can recreate the state. I think with the diffs, you also get privacy because you don't actually know the actual transactions that may happen on your rollup. The blockchain only learns about the differences of balance changes. So we have the ability to practically get privacy for free in a lot of the designs. If you're running permission rollups, you have the ability to get scalability. You also have the ability to do other things around privacy to make sure transfers are hidden between addresses and stuff like that. So all sorts of cool things. It allows us to scale up. It's almost like your CPU of the computer, but in the sense of a blockchain. In the blockchain, the ZK part is your computer CPU, and then the actual blockchain is like your hard disk and memory that's storing this data that's used by the CPU. That's how I see it. It ends up separating components to look like a logical computer that can span globally. But the CPUs are your ZK processors. That's the way it's going. It helps with BitVM and BitVM2 as well, because again, the amount of data required to prove a blockchain could be large, and crunching it down with ZK is necessary. So in BitVM part 2, the paper says you basically do a ZK proof of proving Bitcoin and proving your sidechain, if there's a sidechain, a side system, to prove that you did a burn on the side and you can get Bitcoin out of the vault. So ZK is relevant everywhere. And yeah, there's different forms of ZK, but they all strive to sort of do the same thing.
Do you think that the ZK technology will become more of a priority for institutions and large enterprises as they get deeper into crypto and as the traditional financial system more integrates into tokenization?
I think all CPU, all blockchain computation will be ZK at some point. And the base layers will just be data storage, data ordering, settling, institutional settling, those sort of things. They should be general purpose virtual machines, but they should be just settling systems. and all of the fun stuff will be done in zk, because with zk you can do things like what we're doing with Bitcoin Plus, which is our computational layer on top of our EVM, is a zk layer. What you could do with zk is you can do things like, without a new consensus, without new validators, you could just basically have multiple chains, call them edge chains, that are all proven in zk, and then all of those separate zk proofs are combined into one proof. And because, like I was saying, it was constant time verification, basically, you can put that proof in the base layer and prove that all of these chains, these edge chains, had consistent state. So you get this crazy scaling property. You can have almost infinite level of chains running on top, and you're compressing all that. And the compression is really cheap. It's like logarithmic, so it's really super cheap to do that. The other thing you could do is, if you the problem with having these chains are, no one wants to build in one specific ecosystem. They want to, if they become successful, they want to you want to clone and do your own, right? Like hyperchain, and Uniswap is trying to do Unichain, right? So they end up creating their own ecosystem, and that fragments liquidity. So the liquidity fragmentation is like a huge problem. People understate it. Unless you've been in the Ethereum space for a long time, you understand it. When you have these separate layers and you can't share the liquidity anymore, and people were like, I want the Uniswap liquidity though, but I'm on this other chain, so how can I do that? When you have zk, and it's only possible with zk, you could basically show a proof of one state of one chain and put it on the other. And now you can actually make transactions across these chains, because you're not even borrowing any security. You're basically atomically transferring a message to another, and it's proven. You're zk proven on one, you're zk proving on the other. There's really no assumptions there, other than someone has to relay the zk proof from one to the other. It's really quick. You can do things like, I'm on one chain, I want to do a DEX transfer on another. And it'll feel like one big chain, but allow it to elastically expand and contract based on demand. Yeah, that's like a real big sort of moat that zk will provide for blockchains that maybe the last 1 or 2 years has come about. Polygon, zkSync, these are the front runners that are building that. And we're also we're borrowing on those concepts to put it into Bitcoin Plus. So it's that sort of thing isn't possible unless you go down the road of zk and modular scaling with zk.
Yeah, no, I think that's really important to know. And obviously liquidity fragmentation is an issue that needs to be solved, and the industry is so small compared to traditional finance that we need all the accumulation of liquidity that we can through all the different chains. You know, there's so many different chains that are working on similar but slightly different technologies, and if we just put all of that together and make everything faster, cheaper, more liquid, I think that's what's needed to take crypto to the next level for trading and more assets under management from traditional finance.
Yeah, exactly. Like stock exchanges and HFT bots, and they'll have their own ecosystems and their own tokenomics and maybe their own plans to scale beyond themselves. But if they can share state, and they don't have to worry about some huge state that they have to prove from another chain, they just have to worry about themselves, then from the business perspective, it makes sense to have them separate, but needing to combine them is a technical challenge that only zk can solve.
Looking forward to it. Well, we've touched on a lot of topics, Jag. We touched on AI, quantum resistance, Bitcoin and the side chains, and zero knowledge proof and zk technology. I know your team, there's so many factors when you're building this tech. What are some of the things that your team's focused on in 2025 and in the coming months throughout the summer? What are you going to be working on with Syscoin to deliver next?
Yeah, I think the Bitcoin scaling challenge, like applying, we say merge mining. I think merge mining is a ticket for Bitcoin. I think is undervalued and underappreciated, because when we go back full circle to think, okay, Bitcoin is a capital reserve asset, and all other coins, they will not compete for a capital reserve asset, then how can you extend that? And Bitcoin is not gas, so you can't have a side chain that's going to be using only gas. I actually am a fan of EIP 1559 and the Ethereum tokenomics around an economy that expands and contracts with usage. Those tokenomics need to be built in. Maximalists will hate that you created a shit coin to use as gas because it validates the need for your coin and for investors and all this stuff. But I think there's technical reasoning why you'd want that, and you don't have it compete against Bitcoin because it's not deflate only, but it's meant for a gas perspective in terms of making things as cheap as possible while providing a security budget, while connecting Bitcoin, while making it fully decentralized and secure. So one thing we figured out was because of merge mining, you can borrow security from Bitcoin miners into a sidechain. You're not really transferring it, you're just borrowing it. Because how merge mining works is I'm mining Bitcoin and then I mine sidechain, but I reuse the work, right? If I'm just reusing work, I can attack the sidechain while still earning my Bitcoin rewards, and I can just fork the sidechain and have all sorts of fun with that. And there's no cost to the Bitcoin miner to do that, and that's bad. It's called selfish mining, and private forks and all that stuff become possible. What we did was we added a sort of finality that's optional, and the finality is called multi-quorum chain locks. And our Sentry nodes that are running, it's not really proof of stake, but it's a sort of like checkpointing system that falls back to the traditional Bitcoin consensus if the finality can't be achieved. And that solves selfish mining. It allows us to transfer that merge mining security, not just borrow it. So if someone's trying to attack the merge mining, a Bitcoin miner, you'll have to keep redoing the work every time the finality event happens. So that solves that. The next thing is, okay, now that we have BitVM2, how can we create a sidechain bridge with Bitcoin and not have the honest majority security of Syscoin as the main deterrent for attacks? And that's merge mining makes something possible. It's called merge mining tags that we're unveiling on our next release. And these tags go into Bitcoin's Coinbase output. Some other coins are already doing it, but they're not using it for this purpose. If you put the Syscoin block state into Bitcoin, and you have Syscoin watching for that and validating that I get the Bitcoin header into Syscoin, I check that the Syscoin block hash is embedded into Bitcoin. Now I know if, by looking at the Bitcoin chain, I know if there's anyone that's trying to do any funny stuff, like forking, for example. Because the main attacks to a bridge are that you fork Syscoin, right? You do a 51% attack on Syscoin, you roll it back, you collect the coins again, you spend them from the bridge again. You double spent on the bridge. To stop that, you basically need to avoid forks. So instead of preventing or choosing which fork is valid in a bridge, once the bridge transaction happens on Bitcoin, it's final. You can't roll that back. You're not going to roll back Bitcoin, right? You detect a fork instead of choosing a fork. So we just detect if a fork is happening. And because the Syscoin block hashes are embedded into Bitcoin, when we do the BitVM bridge, we can look at the block headers of Bitcoin, look at the block headers of Syscoin that are passed in. We check to see if any forks are possible, any forks could happen. And if there are any forks, you just freeze and you don't let the bridging happen. And so it's pausing while there's an attack happening, you just freeze. But if an attack isn't happening, you're allowed to use the bridge. So you actually give unconditional security as long as there's one miner that's honest on the network. Like one honest miner would be able to defeat an attack here. So that's interesting, only possible with merge mining because Bitcoin miners are already participating with merge mining. Yeah. It's sort of like if you're in the Bitcoin space and you're listening to this like drive chains. Drive chains is like miners voting for bridging in and out over, I think, 3 months or something like that. And it's very similar, but it doesn't require a fork to Bitcoin in any way. The merge miners are already doing this. It's just a natural extension. It's like a voting mechanism in which chain do you see of Syscoin, and it gives you a lot more flexibility than something like dry chain. So a lot of the big scaling proponents of Bitcoin think that dry chains is the holy grail to scale sidechains to bridge. But I think the concept of using these tags plus BitVM2 gives you that ability and more on the flexibility side. So yeah, that's sort of what we're doing now. And then in the ecosystem, we're launching Bitcoin Plus, and we're doing all these AI use cases and other DeFi initiatives on top. But from my perspective, on the infrastructure side, I'm focusing on getting that connection to Bitcoin happening and making sure that it's secure, it's stable, and it works, and getting people to use that on the institutional side.
Yeah, no, I think that's very important. Looking forward to those updates. I really appreciate your insights all the time into the intricacies of Bitcoin and other parts of the industry and how they're growing, and looking at it from a realistic perspective on where they're at, what are the issues, and that it's going to take time to get all of this technology in there, but this is the way that we're heading. So I can leave a link to some of the latest updates in the show notes and the socials and the site for Syscoin. People can learn more about these different topics that you've touched on. I really appreciate the insights, Jag. I would love to have you back on in the near future and to hear the latest in the coming months.
Sure, sounds good. Yeah, thanks for having me again, and looking forward to, again, like when we go live with some of these things, we could touch on them again.